In this lecture, I am going to take a look at how to start a new thread by using the thread class. A thread is an independent execution path, able to run simultaneously with other threads. A C# program starts in a single thread created automatically by the framework and operating system. This thread is called the main program thread. A program is made multi-threaded by creating additional threads. Here's a simple example. The program starts here in the static main method. The program creates a new thread using the thread class constructor. The constructor expects a thread start delegate as a parameter, and this is the method that the new thread will run. An important thing to realize is that the thread will only run this single method. When the method is completed, the thread will automatically end. And once ended, the thread cannot restart. So in this example, the new thread executes this loop here and simply displays the letter B 1,000 times. But at the same time, the main thread is also running, executing this loop here and displaying the letter A 1,000 times. So what output do you expect to see? Something like AB, AB, AB? Let's find out. I'm running the program now. And here are the results. You can see that the A's and B's are clumped together in groups. And this is because threads are time-sliced. The operating system runs a given thread for a while, and then suspends it and runs a different thread. Each run interval is called a time slice, which is the maximum time a thread can run uninterrupted. So in the output, each time slice is visible as a group of identical letters. Modern computers have multi-core processors that can actually run several threads at once. But at any given time, there are hundreds of active threads in the operating system, many more than the available number of CPU cores. So there is always a certain amount of time slicing going on. There are several ways to initialize a thread. You've seen the thread start delegate for passing in the started method into the thread constructor. However, we don't need to explicitly specify the thread start delegate. The C# compiler is smart enough to infer the delegate from the signature of the started method itself. So this simplified code will also work. Here I pass the startup method directly to the thread constructor, without specifying that it is a thread start delegate. The compiler figures that out all by itself, which makes the code a lot cleaner. Another simplification is to remove the startup method and replace it with a lambda expression, like this. The entire thread startup method is now an anonymous delegate. Again, this is not a problem. The compiler will figure out that the lambda expression matches the thread start delegate, and it will make everything work. Each thread has a name property that you can set. This is especially useful during debugging, because the thread's name is displayed in the threads window. You can set a thread's name just once. Attempting to change it later will throw an exception. So here is a program that sets up to 10 named threads. When I run the program and then interrupt it in the debugger, I can open the Threads panel to take a look at all running threads. You can see the thread names appearing, and when I double-click on a thread, the debugger shows me which code is currently being executed by that particular thread. Finally, let's look at foreground and background threads. By default, any thread you create explicitly is a foreground thread. Foreground threads keep the application alive for as long as any one of them is running. Compare this with background threads. Once all foreground threads finish, the application ends, and any background threads that are still running at this point will abruptly terminate. You can query or change a thread's background status by using the isBackground property. So here's an example. This program starts a single thread that waits for the user to press enter. Note that I set the isBackground property to true, which means this will be a background thread. While this background thread runs, the main thread continues executing the main method until it ends. At this point, the program terminates and aborts the running background thread. When I run this program, you can see that it immediately terminates. The background thread, waiting for a key press, has no effect at all. Now let me change my code and create a foreground thread instead. I still expect the main thread to end, but at that point the foreground thread will still be active, waiting for a key press. And because it is now a foreground thread, the program cannot end until I press enter, thereby ending the foreground thread and allowing the entire program to end. So now, when I run the program, you see that it does not immediately terminate. It continues to run, even though the main thread has already exited the main method. And now, when I press enter, the single remaining foreground thread can end, and now the program ends. So, what have we learned? You create a thread by calling the thread constructor and specifying the method to execute. You can also specify a lambda expression to execute. Threads can have names to aid in debugging. Threads can be foreground or background threads. An application cannot end until all foreground threads have ended.